Hello everyone. So today in this class I will be talking about different direct search methods under unconstrained optimization technique. So we have already talked about this, that basically we have told that nonlinear programming problems are of two types. One is constrained and unconstrained. Okay, so under unconstrained, this unconstrained non-linear programming problems, that means there is no constraint at all, like only fx is given. Okay, and there is no condition for x can vary from minus infinity to infinity. So under this there are various methods. One, we have already told that there is analytical method where we use dy by dx or dfx by dx equal to 0 we do, and then we check d2 by dx to greater than 0 or less than 0. If it is less than 0, then we get maxima, and if it is greater than 0, then we are getting maxima. So this is analytical method, but this is only applicable when fx is differentiable function. But if the fx is not differentiable, in that case it is not possible to use analytical method. So then we have only option, and that is known as numerical method. Okay, so numerical method, under numerical method there are two types of methods. Okay, so there are two types of methods. One is known as direct search method, and another one is descent method. We will talk about that. Today we will talk about direct search method. So direct search, it does not involve any derivatives. We don't require to calculate f prime x or f double prime x. These are not required in case of direct search method. But in case of descent method, we need gradients, or you can say the derivatives. Okay, so direct search method is also known as ungradient, or you can say that uh, one second. Yeah, here. So it is non-gradient method or zeroth order method, because this does not involve any derivatives. Directly we approach, let's suppose if we want to find out the maxima, let's suppose this is the maxima here. Okay, and it is not possible that, let's suppose this function is discontinuous somewhere, okay, or not differentiable. Let's suppose this is the function. So you see here it is not differentiable. Okay, you are able to see. So how you will find maxima or minima? Method will fail, so numerical method we have to see. So in this case what we do, we reach this value, like we start from any value. Let's suppose this is x. Okay, we start from here and we move in either direction, either this or either this. If we see that, let's suppose this is x1, and if we see that x2 fx2 value is greater than fx1, that means we are going in right direction to reach to the maximum. But in case if you find that fx2 is less than fx1, in that case what will happen, that obviously we need to go in opposite direction, means we are proceeding in this direction, isn't it? So that's why it is very important that this is how we approach to the maximum. So this is known as direct search method. Now actually here we don't require any derivative, then it will be known as direct search method. If we need derivatives, if we use derivatives, that means gradient, that means the slope. If we define the slope, let's suppose the curve is like this, see, like this, something like that, or maybe curve is something like this, something. So what is happening here, x1, and this is x2, and somewhere here you are getting maximum. Okay, so by using gradient you can directly reach with the shortest path, so it becomes a little bit faster, this method. Okay, but because it involves these derivatives, so it becomes little complicated also. But in case of direct search method, we don't require derivatives, but in case of descent method we use derivatives, and that's why this becomes faster method. Okay, so let us move to the direct search methods, and see, there are various methods in under direct search method, under which we will discuss only these two, that is dichotomous search method and golden section search method. Okay, and if time permits, then later we will talk about other methods like Fibonacci search method. So there are various other methods, but these two are simpler and good one. So let us see first this. After that we will talk about other methods. Okay, so so how this both method work. Okay, so as already we are seeing here that direct search method, when where it is applied, so first of all the function which or to which we are applying this method, it should be unimodal. Already in the last class we have talked about what is unimodal function. So I have told that, let's suppose there is a function, okay, and in some interval from let's suppose this is A and this is B. In between B, it is only having one peak value, either maxima or minima. Then it will be known as unimodal in this interval. Okay, so under in between this interval, only one peak value should be there. Then it will be known as unimodal function. Clear? So that is very important. So basically this is direct search methods are used for single variable, but this method when it is generalized, it can be used for even multivariable functions. So we will first see the single variable, where how to use these methods in single variable functions, and then we will go for multivariable. So how this works? So it is based on the identification of interval of uncertainty that is known to include the optimum solution point. So although it is unconstrained optimization, that means the function is from minus infinity to infinity, but still we restrict our discussion under a certain interval that is known as interval of uncertainty. That means, we will not check, let's suppose this is the function. So we will not check from minus infinity to infinity, we are not going to check. Rather what we will do, we predict that this function is having a maxima in between A and B, somewhere it is. So is known as interval of uncertainty. Okay, now what we have to do, so there should be guarantee, you should be like confirmed that obviously there is a peak value, or you can say maximum value in between A and B. It should be confirmed. So how do we get this one? That is known as, actually there is a method, grid search method. Okay, so with this method we are able to find out the region in between which we can say that the function is having maxima or minima, or extreme point actually. Okay, so once we got that, okay, there is a interval in which this function has maxima, then that interval is known as interval of uncertainty. Okay, now this interval may be much bigger, that is I is equal to b minus a. So this interval is very large. Now what is there, that we do iterative process, and what we do, we reduce this a and b. Okay, this will shift x1 and x2, so like that it will go on decreasing after every iteration, and ultimately we come to the a very small interval. Okay, uh, where we get, and in between that interval we get the maximum value. So this is how all the direct search method work. So what we do, we generally reduce the interval of uncertainty. So that is the method. So all the direct search method differ only in the method of reducing this interval of uncertainty, right? And the concept is same. So let us talk about the method itself. So here it is written that both the methods seek the maximization of unimodal function fx over the interval a and b. Okay, and this interval is going to include the optimum point x0. We know that. Okay, and so both methods start with an interval of uncertainty, that is ab, which is known as initial interval of uncertainty. So from here we will start our discussion, or our you can say solution. So we will talk about the steps. So here, so we will see general steps. Actually we will simultaneously see both the methods. Okay, because both have certain advantages and disadvantages. Actually this method, this is golden section method, is much more advantageous than the this method. So we'll see that. So general step, let's suppose any step I, we talk about this step, because there will be many iterations, isn't it? This is the initial, this is the 0 iteration number 0, so interval is I0. If iteration number 1, then interval will be I1. Okay, so see here, let I minus 1 is equal to xl and xr. Okay, be the initial, or you can say current initial current or initial is same only. So current interval of uncertainty. Okay, where xl is actually a and xr is b. A and b are any value. Okay, now we need to identify. So this is the first step. Okay, and now what we need to do, identify x1 and x2, we have to find out x1 and x2 two terms. How do we find? So there is a formula for it. Okay, we have to just remember those formula, and let's go to next slide. Okay, so here let me write this dichotomous method, and here I am writing golden section method. Okay, so what are the formulas for x1 and x2 in both the cases? So here x1 is calculated as 1 by 2 of xr plus xl minus delta, and x2 is a1 by 2 xr plus xl plus delta. In this case, x1 is equal to xr minus root under 5 minus 1 by 2 into xr minus xl, and x2 is xl plus root under 5 minus 2 into xr minus xl. Okay, so x1 and x2 is calculated. Now next what we will do, I will explain this one, and this just remember, actually the value of this one is 0.618, so just take that one. First of all, understand the method. After that we will talk about why these all things are taken. So after x1 and x2 calculated, what we will do, calculate fx1 and fx2. Okay, now conditions. First condition, if fx is greater than fx2, so what will happen? In that case, in that case the optimum will lie in between xl and x2. Now what is this, what is the meaning of this? So let us suppose take this example. Okay, here we have this is xl and this is xr. Here right now it is a and this is b. Okay, a and b points are there, so xl is taken a and xr is b. xl and xr are actually variables, left x and right x. Okay, and take 2 points in between somewhere. This is x2, and let's suppose, oh, x1 is higher, no, so just take this one, x1. So see here, it's telling that if you have calculated and found that fx1, this is the point, fx1 is greater than fx2, so the interval will change. Now what we are going to do, we are going to sort the interval. So where, so it is telling that the interval will now be this and this. We have to check only this one. Why? So this interval now is excluded, we will not consider. Why we will not consider? Because fx1 is greater, so obviously when the function is increasing in this direction, so obviously the maxima you are going to get is in this direction only. So why we will go for this area? There is no use of checking this area, isn't it? Are you getting? In between x2 and x1, so in between this only somewhere this maxima will be there, so we can exclude this value. Okay, In case what happens that if suppose this is the function and here is a and b, in case what happens, this is x1 and this is x2. Okay, so this is xl and this is xr. So here you see fx1 is less than fx2. In that case what will happen, the maxima will lie in this direction. So this we will consider and this we will exclude. That means now xl will shift here and xr will be this only. Clear or not? Similarly here what was that, this xr was shifted here. Are you getting or not? So xr was shifted to x2 and that's why it is written that now the optimum will lie in between xl and x2. Clear or not? And here the maxima will lie in between x1 and xr. So write down second condition is that if fx1 is less than x2, in that case what is going to happen, that the function the maximum will lie in between x1 and xr. So x star is will be in between x1 and xr. अच्छा, let's suppose that both are equal. आपने ऐसा करा कि both equal आ गया. If fx1 is equal to fx2, in that case what will happen? So very simple. Okay, I'll put here. Let's suppose this is the function and while calculating you found that this is x1 and this is x2 and both are equal. fx1 and fx2 are equal. That means that the function will be lying in between x1 and x2. So if this is xl and this is xr, so now xl will shift up to x1 and xr will shift to x2. Okay, so the interval will drastically decrease. Okay, so that is beneficial, but it rarely happens. Okay, so x star will lie in between x1 and x2. Okay, so this is the method. So what we are doing, actually we are decreasing the interval. Okay, step by step. So in next step, now this is changed. Okay, here you see xr is now x2. If this happens, then xr will be now x2. So replace xr with x2 and then calculate x1 and x2 like that. So every interval we will be going like that. Same case is with this one also. So let us solve one problem and then we will understand much better in much better way. So take the screenshot of it and then we will move to next. Okay. Okay, so see here, question is uh, this is maximize fx is equal to 3x in between x in between and 1 by 3 minus x plus 20 when x is in between 2 to 3. Okay, so this is the function, although this is unconstrained function. Okay, but there is an information that this function is like will have the maxima in between 0 and 3. Okay, so we have to check in between 0 and 3. So we have initial that is I naught is 0 and 3, and let us suppose or let us assume that delta value is 0.1. Take it with which we will shift. This is the interval. Okay, so let us start So first I naught is we got. So let us take the iteration number 1. So iteration number 1, x1 we will calculate and x2 we will calculate. In case of we will use the method dichotomous. So we are going to use the dichotomous method. So dichotomous we are going to use. So x1, what is the formula for x1? So x1 formula is 1 by 2 xl plus xr minus delta. Okay, so put it 0 plus 3 is 3 minus 2.9 by 2, that is 1.45. So x2 1 by 2 xl plus xr plus delta, that is 1 point, this is 3.1, that is 1.55. okay, so calculate fx1. So this x1 is lying in between 0 to 2, so we will use this formula. So 4.35 and fx2 is equal to 4.65. So which one is greater? Fx2 is greater than fx1. So here what we got, fx1 is less than fx2. That means just check this. Okay, this is xl, this is xr, and fx1 is less than. Okay, it means x1 is less than fx2. That means this direction. तो ये वाला हम interval को छोड़ देंगे. तो xl will be x1 now, and so new interval we are getting. So iteration 2, यहाँ पे आपको i1 मिल जाएगा. तो i1 कितना होगा? So i1 we will get is from x1. So what is x1? 1.45, and xr is 3 only. Okay, so now we have got, this is now xl and this is xr. Put this and find out. See, now the actually termination we have to see. कब ये terminate करेगा, कितना iteration के बाद terminate करेगा? जब जो interval है वो बहुत कम हो जाए, ये इन दोनों के बीच का जो gap है वो बहुत कम हो जाए. शुरू में कितना gap था आप देखो, 3 था. 3 minus 0 is equal to 3. Here now the gap has decreased. Within one iteration you see the gap has decreased to 1.55. that much has decreased. Are you getting or not? So if that gap has decreased up to this one delta, then we will stop there. तो अभी तो बहुत ज़्यादा है. Let's move towards further. तो x1 हो गया, x1 फिर से निकालिए. x1 will be in this case xl, so half 1.45 plus 3 minus 0.1. How much is this? So I have calculated, you just calculate that, and we have got 2.175. and what is x2? 1 by 2 1.45 plus 3 plus 0.1. This is 2.275. okay, now calculate fx1. Put that value. So this is 2.175. so you will use this one or this one? Obviously this one you will use, because 2.175 is in between 2 and 3. This one will be equal to 1 by 3 into minus 2.175 plus 20. That will give you 5.942, and fx2 will also be same. This one formula only we will use, 5.908. So you see here now in this case fx1 is greater than fx2. अब क्या हो गया, fx1 मतलब ऐसा है कुछ, है ना, ये x1 x2, तो fx1 is greater, तो ये गया काम से. तो इसका मतलब हमारा जो इंटरवल होगा वो कहाँ से कहाँ तक होगा, तो xl एंड x2 के बीच में होगा। तो xl अभी क्या है, so the next iteration value is xl and x2 is how much here, this is the x2 2.275. so you can understand, you can see that now the gap has decreased. How much it has decreased, so check it. This is 5 and this is 7 and this is 1.175. This was around 1.55, now it is 1.175. okay, so like that you have to move iteration by iteration and you have to calculate the value. So this is the dichotomous, and once this gap, this value has decreased, or you can say up to 0.1, then we will stop there. Okay, so let us actually in this case we can use the Excel, and that will be much easier. We have to just program it in the Excel, and then we will easily solve, because I don't know how many iterations it will go. So let us see once. 1 second. Okay, I'm deleting it, so please take the note, or you can take the screenshot of it. Okay, so I'm just removing this all. Okay, so this was the question, and you can see actually I have taken it from a book, and you can see that this is made in the Excel, and how many iterations has been done. So this is 0 iteration. Oh, this is first iteration. So like that it is around 15 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 iterations. After 20 iterations we are getting the values. You see XL and XR, the difference between this is 0.1. now you check it here. Okay, so it is less than 0.1 basically, because it is 0.09000. so obviously it is not possible with it will be very difficult manually doing, but with using Excel or any other programming languages you can easily solve this one. So in the examination if it comes, then come up to 2 iterations, find out the values of x1 and x2 or xl and xr after 2 iterations. That much only they will ask, because once you know the method, then you can easily calculate complete values. Are you getting? So next method is, this is dichotomous. Actually we have used here the programming, in the programming actually when you put x here, then that means this will calculate using dichotomous search method. But if you put x here, then it will like you see here, x is put here, so this will calculate using golden section method. So you can see in golden section method 1 2 3 4 5 6 7 8 9, almost half. You see that time it was around 20 and it is around 9 iteration. It is now converging. The difference is lesser than 0.1. So we can understand it's so fast. Actually golden section method, it's much advantageous. So we can use both the methods, we can solve both the methods using both the methods. Okay, so so should I solve using golden search method also, golden section method? Okay, let me do that also. One iteration I'll do, and after that you can continue with that. Okay, so see here, so golden section method. So one, first of all we know I naught is given 0 3, means xr and xl is given, sorry xl and xr, xl is 0 and xr is given. Okay, so first of all find out x1 and x2. So what is the formula? X1 is equal to xr minus it was root 5 minus 1 by 2 into xr minus xl. This was that. Clear? And x2 is equal to xl xl plus 0.5 minus 1 by 2 into xr minus xl. Okay, so put that values here. xr is 3 minus, what is this value? 0.618 into 3. How much is this? This is around 1.146. so fx2, put it fx1. So this is it will come here, so 3 into this value, that will come around 3.438. okay, here you see xl 0 plus 0.61 into 3, that is coming 1.854, and fx2 is equal to how much? 5.562. so here we are getting that fx1 is less than fx2. so draw the diagram you draw, don't be confused, because see, this is xl, this is xl, and it is telling that x1 is less than x2, means this is x1 and this is x2. so obviously this one will be removed, so xl will shift here and xr will be this only. okay, so xl become xr, so I1 will be this 1.146, and this one is 3 only. okay, so in next iteration similarly we will solve. okay, we will stop here, and you can try one problem, this one, and maximize this using dichotomous search method. Actually here the question will be, it should not be maximized because you have to use Excel sheet. so what you have to do is you can do one thing. Yeah, like the question is find the values of XL and XR after after 2 iterations. okay, so this is the question, this is your assignment to do. okay, so thank you very much.